Welcome to the Building Big Data Pipelines with SparkR, Tableau, and MongoDB course. In this course, we will be creating a big data analytics solution using big data technology specific for R. In our use case, we will be working with raw earthquake data, and we will be applying big data processing techniques to extract, transform, and load the data into usable data sets. Once we have processed and cleansed the data, we will use it as a data source for building predictive analytics and visualizations. So one of the tools that we'll be using, like the one you can see in front of you, is Tableau Desktop. So this will be our visualization tool. We'll be taking the data that we have already processed and then visualizing it, creating visuals, creating maps, etc. So what Tableau Desktop is that it is a powerful data visualization tool used for big data analysis and visualization. It allows for data blending, real-time data analysis, and collaboration of data. So no programming is needed for Tableau Desktop, which makes it a very easy and powerful tool to use in order to create dashboard applications and build reports. And our processing engine will be SparkR. So SparkR is an R package that provides a lightweight front end. So it's almost like an API, basically, not really a front end, to use Apache Spark from R. So it allows us to interface with the Apache Spark library using the R programming language. So SparkR provides a distributed data frame implementation that supports operations like selection, filtering, aggregation, etc., but on large data sets, right? So the library is optimized to process data specifically on large data sets. SparkR also supports distributed machine learning using MLlib. MLlib is a library that is used for machine learning that is optimized for working with large data sets, in other words, big data. So lastly, we will also be using a NoSQL database called MongoDB. So what MongoDB is a document-oriented NoSQL database used for high volume data storage. It stores data in a JSON-like format called documents, and it also doesn't make use of row column tables like your normal SQL relational tables. So the document model basically maps the objects in your application code, making the data easy to work with and interface with. So what you'll be learning in this course is you will learn how to create a big data processing pipeline using R and MongoDB. You will also learn machine learning with geospatial data using the SparkR and the MLlib library. You will learn data analysis using SparkR and Tableau. You will learn how to manipulate, clean, and transform data using Spark data frames. You will also learn how to create geomaps in Tableau Desktop, and you will then combine everything that you've learned and ultimately be able to create dashboards in Tableau Desktop. So after all the heavy lifting that we will do in the back end or the background, we'll be able to use the data once it's been cleaned and transformed and summarized, and then we'll be able to create a dashboard like you can see in front of you. So basically what you see is the earthquake prediction map. So basically this is earthquake magnitude values that are predicted using the MLlib machine learning library for Spark. So we basically train the model on earthquake data ranging from 1965 up until 2016, and then we predict a year's worth of data, which is earthquakes for the year 2017, and then we plot them on our geomap, as you can see. So each point represents a predicted earthquake magnitude value, as well as its location using the latitude and longitude values, as well as the name of the place where we're at. And then you'll see there's a color palette of blue, so the darker blue points depict a greater earthquake magnitude, and then the lighter blue points depict a smaller earthquake magnitude. So you can see the difference between the lighter one, it has magnitude 5.8, and then the darker dot has a magnitude of 5.9. Okay, so you can easily distinguish between the earthquakes with a greater intensity and those that don't have such a great intensity. Okay, so as you can see, our main view is our prediction map, right? And then we'll also be creating multiple visualizations. I know now that everything is done, it looks simple, neat, but it takes quite a lot of work, and we will be covering all of that. So here we have a scatter plot, or a bubble plot if you want to call it that, of the number of earthquakes for each year. So you can see on the x-axis we have our year timeline, and then we have the counts, so the number of earthquakes for each year starting from 1965. And you can see that we are also using a color palette. So here we have sort of an outlier, but actually not. So it's the year 2011, and we can see that it has the greatest number of earthquakes. Therefore on the right we have sort of like a menu, right? So we have the predicted magnitude, we have the counts, and in the predicted magnitude we can also see the shades of blue depicting the intensity of the earthquake, as you can see on the map as well. And then we also have the number of earthquakes, the counts. So you can see we're using a color palette between green and blue. So the darker blue color depicts a greater number of earthquakes for that year, and the darker green color depicts a smaller number of earthquakes for that year, as you can see over here. Okay, and then we'll also be plotting we will be creating a stacked bar chart, okay, where in each bar we're representing two values. One is the maximum magnitude for the same year, and then if you hover below that, we'll be displaying the average magnitude for that year. So we're displaying the average and the maximum magnitude of each earthquake side by side in a stacked bar chart. As you can see over here, not only do we have the greatest number of earthquakes, but we also have the earthquake with the greatest intensity in 2011. So something really wrong has happened in that year according to our data set. Okay, and then we also have a donut chart of the different types of earthquakes within our data set. So the majority of our data in our data set consists of standard earthquakes, and then about 0.75% of our data consists of nuclear explosions, as you can see in a tiny color over here, a tiny slice of blue. So if you go to type, we also have a legend for our donut chart. So here you can see that there actually are some other values in our data set. So we have earthquakes, standard earthquakes represented by a green color, and then we have explosions, and then we have nuclear explosions and rock bursts. Okay, maybe you can see it if you hover over it just a little bit. Okay, so this is basically the dashboard application that we will create. So we can also perform an analysis after we have created our dashboard, which is also partly why Tableau is used, so that people who don't necessarily code but want to interact with the data are allowed to do so, because all the heavy lifting has already been done in the background. So for instance, if we want to search for a region and just have a look at the predicted earthquake values for that region, like Fiji, you can search for it. There's a built-in search tool. So now we see all the predicted earthquakes surrounding the Fiji region. If I hover over one of them, you can see it's a place in the Fiji region. You can see a great magnitude of 6 over here, and you can see the rest of them where the earthquake is more intense versus this area over here, which consists of earthquakes that are not as intense compared to the ones on the left. Okay, and then there are other things that you can do with Tableau if you want. You can also select a single point and then explore that. You can select multiple points, and you have options here as well for what you want to do. Okay, so yeah, so that's the application or dashboard application that we will be building. Like, there's multiple ways of doing this, but the most efficient and fastest way to create these dashboards is using powerful tools like Tableau. So we'll be building an end-to-end solution, all the way from collecting the data and having no code to writing all the code, doing the transformations, building the machine learning models, doing the predictions, and then creating the summarized data. And then we will be creating the dashboard for that. So I hope you guys will enjoy this. This is quite a good course, and it's a good set of tools that you can use. And obviously, once you have built this, you are welcome to modify it and create whatever else you want. And one of the things to notice is the donut chart, which doesn't exist in Tableau. So all there is a pie chart. So I'll be showing you how to create one. So there's ways to do things. So it's not only limited to the visualizations that Tableau offers, but you can also create your own custom visualizations using smart tricks. Okay, and I'll be showing you that. So yeah, if you want to view this in presentation mode and you don't want the whole layout of the dashboard, you can click on this icon over here, and then you can see we have a greater view. Okay, so that is it for this video. I really hope you guys take this course, and I really hope you guys learn a lot. As you'll see, the more of these courses that you take from me, the easier it will be to create these applications. So there's I think a shortage of big data applications for R. There's a lot of PySpark and Python related big data applications, but I think we should be flexible and be able to create the equivalent applications in R as well. So thanks a lot for tuning in. I'll see you guys in the course. Thank you.